Okay, everyone, we are live and let's get back to our app where we left our last concept, which was regarding the usage of hexadecimal numbers. Okay, so we basically discussed the four uses of hexadecimal, which were basically MAC address, IP address, color codes, error codes, and all that. We had a great discussion on this last night, yesterday at the same time. And today we are basically going to be starting off with a very, very easy concept known as logical shifts. Okay, logical shifts. So, what do we mean by logical shifts? Basically, logical shifts is a concept where when I want to, let's have a binary number 1 0 1 1. Perhaps let's add a zero up here. 0 0 1 0 1 1 0 0 1 2 3 4 5 6 7. So we have an 8-bit binary number. 8-bit binary number. Okay. So we have an 8-bit binary num, and let's say I ask one of you. Let's say I ask Cristiano to shift all the ones to the left side. In other words, let's say I want to bring this one up here, bring this zero up here, bring this one up here, or in simple words, like shift every element to the left side. How? Like the zero could go up here, and let's say we only have 8 slots, so the most left one is just gonna go into some vein outside, like it goes up here, this zero come up here, and then this is zero, and we get this one up here, and this zero up here, then 1 1 0 0, and finally we have like a new element. Like for instance, let's have the values, that way it would be much more clearer. 1 2 4 8 16 32 64 and 128. Okay, we have these values. Now let's say I ask someone, Cristiano in this case, to shift all the numbers to left side. Okay, I want you to shift the numbers to left side. How am I going to be shifting the numbers to the left side? Just wait a second, guys, just a second. पता नहीं क्या हो गया. 32 and this is 16. Okay, logical shifts concept, new concept. So yeah, start से करते हैं. So okay, 1 2 4 is 16 32 64 128. Now I want you all to shift each of the element to left side. How am I going to do that? One simple way is कि बंदा manually करे. Okay, this zero is going to take the 128 place. This one will come under the 64th element. This 0 will come under the 32 element. This one will come under the 16. 4 will come under the 8. 0 will come under the 4 1 0. And then the 1 is going to take the 2's place. Okay. Now, there is a question. Once we take a logical left side shift, like you see, this shift is known as a logical left shift. Like what did I do? I just shifted all the numbers to the left side. Shift to the left. Okay. Shift to the left, to the left. If I shift all the digits to the left side, what is going to happen? There is a missing bit up here. Like this zero, this goes out. Okay, why does it goes out? Because I clearly said that we have an 8-bit binary. Okay, but if I shift the 8th element, because this is the 8th element, right? If I shift the 8th element to the left side, it goes to the 9th section. But our register can only contain 8 bits binary. It will ignore any number which is greater than 8. So the 9th bit is basically going to go to the left side, and we are just going to ignore it. Now what happens? We have a plain digit up here which doesn't have 0 or 1. So whenever we have a scenario where we have to add something to just fill up the register, we are always going to be adding a 0, whether it's at the most left side or at the most right side. Whenever we have a blank space for some digit, we are always going to be putting a 0. Now why a 0? Because if you guys remember, I said at the start, ignore all zeros. Ignore all zeros. We will only be dealing with what? With ones, right? We are only going to be dealing with ones. Now, even if I put a 0 up here, eventually we have to ignore it. So it has no value. It won't create any impact on your final answer. However, if we do put a 1 up here, let's say I put a 1 up here, then it will change the final answer. For this reason, whenever we have some sort of a blank, yes, we will be discussing overflow later on, but right for now, if whenever I have some sort of blank digit, I will always be putting a 0 in it. But now there's a question. I said that this is an 8-bit register, okay? And when I say 8 bits, what do I mean? Remember the example I gave yesterday, not last night, but we have a big shelf and then there are 8 columns in it, 8 rows perhaps. Columns, 1, 2, 3, 4, 5, 6, 7, and finally 8. Now this digit, this 0, this goes to the ninth section, okay? But we don't have a specific slot for this zero to be stored in. So this zero comes out of this entire table thingy, and now it's nowhere. Now, whenever such thing happens where we cannot store a number within its specific table slot, this is called an overflow error. Overflow error. So overflow error basically is a type of error in which the number which we are trying to store, it does not have the specific register, does not have enough capacity to store it, and so we just ignore the number and it goes out and it's like finished. Okay, we don't have that number in our calculations anymore. So this zero currently is at an, why is the camera off? Okay, so this zero currently is at the ninth position, which does not exist. Why it doesn't exist? Because I clearly mentioned that we are only dealing with 8 bits binary number. So when we have 8 bits and we include a ninth element in it, the ninth element doesn't exist, because if I said like it could have been an 8 bit, but let's say for instance I had another register which was a 12-bit register. Okay, a 12-bit register. Now a 12-bit register will be something. Do can we make shapes? Let me see. You should be able to make shapes, right? uh Oh, yes, we can. New thing learned. So we have this big sort of like a table or something, and then I make 12 sections. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and then finally 12. Now, if I take the same example, we had what? We had a 0, 0, 1, 1, 0, 1, 0, 0. Now, if I perform a logical left shift, which means that I will be shifting each element to the left, what's going to happen? I will bring the 0 up here. Okay, this will come up here. This is going to go up here. Then a 1, then a 0, then this 1, then this 1, then this 0, and finally this 0 comes up here. And because we have a blank slot at the most right hand side, we are just going to be putting a 0. And likewise, if we have a 12-bit register, like you see we have a 12-bit register, but we perform the calculation on an 8-bit register, you see we have these 3 slots left. These are empty. So what am I going to do up here? Whenever we have any sort of empty slots, we are always going to be just inputting zeros. So we will have a 0 up here, then a 0 up here, and then a 0 up here. Now, even though, if I just like look at the values, what's the value for each of the position? This one is 1, and this is 2, and this is 4, and this is 8, 16, 32, 64, 128. This continues because it's a 12-bit register. 256, 512, 1024, and finally 2048. How did I get to know? I'm just multiplying the previous value by 2. Okay, but now the thing is, even if I have zeros up here, but if it doesn't have 1 in it, will we take this number into calculation? No, we are always going to be ignoring the zeros. It's our first rule: ignore all zeros. We are only going to be dealing with the ones. So even if we put a million of zeros in this at this side, like a millions of zeros, and it goes up to like some quadrillion number, even if there is like hundreds of zeros, but we don't have a 1, then we are only just going to be ignoring that, and we won't be taking that into consideration. So even if we perform this shift, the answer is just going to stay the same. Just like that, this concept basically, when we convert or shift the numbers to one left side, this is basically known as logical left shift. Left shift. Now in your exam, they could either tell you that, let's say, Ahmed is a user who wants to perform a logical left shift on the following binary number. What will be the final answer? Now they will be giving you something of this sort, and then in the next section you will have a similar table or a similar register made up, and you just need to perform a logical left shift. Okay, and logical left shift has a short form known as left logical. Wait a second. It will, oh yes, LSL. LSL is basically the short form. They will usually give it, but this is something which they usually test in A levels. But just for your own knowledge, if they give you an example or a short form of LSL, know that they are referring to logical shift left. But whenever they say LSL in your exam at O levels, they will clearly mention that it's logical left shift. Okay, and likewise, there could be a logical right shift too. What will be a logical right shift? Let's copy the same exact thingy. Just a moment. How do you do it? Copy this, Control C, and then a Control V. No, control C and then a control A. Okay, it doesn't get copy. So let me make it again. So we have a straight line up here, and then we have something like this and like this. Again, 12 boxes, 1, 2, 3, 4, 5, 6, 7, 8, 9, let's say 10. And then we have a number like 0, 1. Oh, my bad, my bad, my bad. Let me get it up here. 0, 1, 1, 0, 0, 1, 0, 1, 0, 1. Okay. Okay, guys. मेरे को पता नहीं ये कौन सा question आ गया, just a confusion. But no worries. अच्छा, so guys, have a look. We have the same binary number 0, 1, 1, 0, 0, 1, 0, 1, 0, 1. Now the question says perform a logical right shift. Right shift. Now, when it says right shift, what do I need to do? I just need to shift all the numbers to the right side. Now, if I exactly make the same thing, what's the answer going to be? I will be having, let's say we had 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, this one is going to go outside to this section. It's going to come up here. And this 0 is going to come up here. This one will come up here. This 0 is going to come up here. This one will come up here. This 0 will come up here. Then again 0, 1, 1, 0. Now, what do you see? We have an overflow type of thingy happening at the most right bit. But because we clearly said that it's a 10-bit register, we don't have space. See, we don't have space for this one. This one is just gonna get ignored. It's gonna go out. We will just remove it from our numbers. Okay. But at the same time, you see we have an empty slot up here. So what do we have to do? In the empty slot, we just need to put a 0. Okay, so that's the main concept. Whenever a question says logical left shift, you just need to shift all the numbers to the left side. Logical left shift. Okay, the question could be something like perform a logical right shift x2. So when it says x2 or 2 times, it means that you first need to get to this answer, first step. Okay, and then you again need to perform another logical shift, lsr will mean logical shift right. Okay, so again perform logical shift right. This 0 is just going to go out. We are going to ignore it, and then we will have 1 0 1 0 0 1 1 0 0, and then again we will have an empty slot at the most left hand side, and we're just going to be putting a 0. But now the important thing is, this concept is easy, guys. No, the thing is beforehand the one was at 1, like the value for this position was 1, right? We guys know that 1 has the value 1, whereas this specific 0 portion has a value of 128. Just for instance, let's consider this as like a 8-bit register, and the most left thingy will have a 128 values, right? So if I perform a logical shift right, and this one goes up here, and then we have an empty slot up here, this empty box won't be having 1 as the value. It will be having 128 as the value. So if I bring the 1 up here, it's going to be giving me a wrong answer. Yes, I'm explaining. So the function, why do we need logical shift left, right, or right side? The concept behind this is, or what do we call, firstly, Emma, did you get it why we don't have these, like, okay, perfect. Now the impact or the reason. Let's say I have a binary number which has a denary. Let's make a binary number of 8-bit. Yes, exactly. So let's say I have a value 1 0 0 1 1 1 0 1 2 3 4 5 6 7 2 3 4 5 6 7. Okay, what's the value, denary value? 1 2 4 8 16 32 64 and 128. We have the binary value or denary value as, we have it as 2 plus 4 plus 8 plus 64. Calculated, it's going to be 10 plus 14 and 14 plus 64, 64, 68 and 78, right? It's 78, right? Can anyone confirm? Yeah, it should be 78. Okay, 78. Now if I want to perform a logical leftward shift, what's going to happen? Whenever, remember, let me import it, whenever I perform a perform a logical leftward shift, LSL, logical shift towards the left side. Okay, this is just a shortcut. If a question comes, you need to write logical shift left clearly, but just for now, LSL, logical shift left, the value will always get multiplied by 2. The value will always get multiplied by 2, multiplied by 2. Let's say I perform a logical leftward shift on this specific binary number. What's going to happen? This 0 is just going to go away because it will come under the overflow thingy section. And then we will have the number as 1 0 0 1 1 1 0. And finally, because we will have an empty slot up here, we are just going to be putting a 1 up here too. Now, 1 2 4 8 16 32, 64, and 128. So if I add up the new binary values, this is the shifted one. Shifted. Shifted binary number. Okay, this is the shifted binary number. Add it up. 128 plus 16 plus 8 plus 4. Let's just save up the time by doing it on calculator real fast. Just a moment. 128 plus 16 plus 8 plus 4. So it's 156. Now, guys, 156 is the exact double of 78. If I do 78 multiplied by 2, let me show it up if you guys can see it on the calculator. It is 156. Can you guys see? It's 156. So this means that when we perform a leftward shift, the value will always get multiplied by 2. Now, the purpose, someone asked basically the summary, like what's the function? Let's say I have a binary number and I'm asked that, no, I want to double the value of it, double the current binary value. So rather than just finding like 78 times 2 is 156 and then plotting ones again and again just so that I could get a 156, the easier method is that I'm just going to be performing a leftward logical shift. So I will be just shifting all the values to the left side. Now, coming back to the same question, Ahmed, if you remember, you asked that if we have an empty slot, why don't we put the 1 up here? Now, if I put a 1 up here, the value won't be 156. It's going to come up as a 157. Right? So the answer is just going to change. So for this reason, whenever something goes out of the box and it's in the overflow section, we just ignore it. A question can come that when we have the 8-bit and then the 8-bit goes out, like, okay, this 0 goes out to, we ignore the 0 and an error is caused. Write the name of the error. So the error name is basically overflow. So the error caused when a bit goes to the overflow section, to the overflow flow area, is known as the overflow error. It's important you guys know overflow error. This can be a question. Okay, they can ask you about this. It's really something you guys should be knowing. Just a moment. एक second, guys. A friend of mine just called in. Just a second. Okay. Yeah, guys, 2 minutes. Bro, class meeting. Just a moment. Guys, can you guys just give me 2 minutes? It's something urgent. Okay, 2 minutes. Just a moment. अच्छा सॉरी गाइस, थोड़ा सा कोई सीन हो गया था, हाँ, लेकिन जस्ट अ मोमेंट यार। एक तो ये जो चीज़ें क्लास से बाहर इस टाइम पे, मैंने नेक्स्ट टाइम नेट बंद कर दिया करूँगा, लेकिन 2 मिनट। अच्छा, सो ऐसा है, आप लोग इतना ज़रा 2 मिनट डिस्कस करो, मैं 2 मिनट में बताता हूँ। सॉरी गाइस, सॉरी, या एवरीथिंग इज ऑल फाइन। बेसिकली मेरा एक दोस्त है, तो उसने ज़रा यूनिवर्सिटी की फ़ी चालान पे करना था, एंड 5 मिनट्स में बैंक बंद हो रहा है, तो उसने कॉल की है कि वेदर आई हैड एन अकाउंट इन दैट बैंक और नॉट। सो कमिंग बैक, सॉरी फॉर द डिले एंड फॉर द डिस्ट्रप्शन। नेक्स्ट टाइम इंशाल्लाह नहीं होगा, बट दिस हैपेंस समटाइम। सो आर वी गुड टू गो? शुड वी स्टार्ट अगेन? ओके ओके गाइस, चलो, ऐसा है। ओके, लेट्स स्टार्ट ऑफ अगेन। So where did we left? Okay. So see guys, an error which is, एक सेकंड, मुझे ये लैपटॉप पे ना व्हाट्सएप बंद करने दो। यहाँ पे जब कॉल आती है ना तो बड़ा मसला होता है। So an error when a bit goes to the overflow area is known as the overflow error. Now you won't be asked to describe it. लेकिन the question could be something like they give you a line on something. Okay guys, for instance, they say that the 8 bit where we had a 1 previously, it no longer exists. Where did, oh, an error caused, what is the name of this error? So you're just going to be writing these two words: overflow error. No need of description, nothing. It's just going to be stating the word. Okay. Now, we learned that when we have a leftward shift, the value is going to get multiplied by 2. But we also saw that we also perform a logical right shift, right? So this means the right shift also has some sort of power, right? Now, what's the importance of rightward shift? So the power which the right shift basically has is that when you perform a rightward shift, the value is going to get divided by 2, is going to be divided by 2, divided by 2. Just a second. यार उनका नंबर ज़रा बंद आ रहा है, शायद वो यूनिवर्सिटी में हो, तो अगर घर आते हैं तो फिर उसके बाद मैं चेक कर लेता हूँ, अगर अभी शायद आना तो होगा उनका, फिर मैं देखता हूँ, लेकिन अभी तो नंबर बंद आ रहा है। Acha. So when you basically perform a rightward shift, the value is always going to get divided by 2. So what do I mean by divided by 2? Let's copy the same example which we discussed earlier. 0 1 0 0. So we had a 0 1 0 0 followed by 0 1 0 0 triple 1 0. Now we know that this specific number gives us the denary value of 78. Now this means that if I divide this value 78 divided by 2, it should be what? Just a second, calculator ki tarah hota hai yaar. Let me know guys quickly. What's 78 by 2? Use a calculator or whatever. Make your mental math as good as possible. आप लोग को इसकी काफी जरूरत होगी. 39. Okay. So this means our final answer should be at 39. Okay. Answer should be at 39. Now let's perform a rightward shift on it. Okay. So what's the rightward shift going to be? The 0 is going to go away. Okay. And we will have 1 1 1 0 0 1 0. And we have this slot up here which will be replaced with a 0, right? So this binary number 1 1 1 0 0 1 0 0. Okay. Now what's the denary value of it? Calculate it. This will be 1. This is 2, this is 4, this is 8, 16, 32. So now just add it up. 32 plus 4 plus 2 plus 1. It's 36, 36 plus 2 is 38, 38 plus 1 is 39. So guys, both of them just matched. So a 39 equals to 39. So when we have both the values matched, this basically confirms and it proves that yes, a rightward shift means that the value is going to be divided by 2, whereas a leftward shift will mean multiplied by 2. Now if I say that you need to perform a logical left shift 2 times LSL, my bad, I always mix this. But if I say I need to perform a logical shift towards left 2 times, this means that first the value will be multiplied by 2 once, and then once we get the newer value, that will be again multiplied by 2. So if we had a value of 10 at the start, the final answer is going to become a 40. How? Because it's going to multiply by 2 and we will get 20 first, and then 20 multiplied by 2, we will be getting a 40. And if a question comes up directly, what I can do is I can do like something 11001100. If I want to perform a logical shift left x2 2 times, so rather than moving on one side for one digit, I can directly make 2 jumps. Like this 0 can come here, like 0, this 0 could come up here, this 1 could come up here, and then I can like just complete the whole thing. 0 0, these two could, both of the two could go into the overflow section, and this 0 0 are just going to get replaced. Okay, something like that. So yes, Saifullah, do you have a question? सर आपका पहले से स्टार है, मुझे इतना पता है guys. We have I believe Sir Abbas with us, the very dedicated, goated teacher of mine who taught me IGCSE physics, and he is the legend behind me scoring a perfect 40 on 40 in my physics MCQs. And अगर ये बंदे ना होते ना, so I really messed up my ATB paper. We didn't have theory paper because of the 9 May incident, and it was because of this legend, goated banda, who made me get that perfect 40 on 40 score on my MCQs paper. And sir, thank you so much, guys. Physics ki class and Sir Abbas, absolutely 1000% recommended. An absolute goat, absolute goat. So, बिल्कुल कोई शक नहीं है, कोई शक नहीं है. So we are done with the logical shifts. Is this clear? कोई questions या कुछ है तो बताएं. It's a pretty simple concept, I guess. इसमें तो कोई इतनी confusion वाली बात होनी नहीं चाहिए. सही है. Oh guys, अभी नहीं restart करना. अब बाद में आप updates install कर देना. So my laptop was just about to get restarted, but no, अभी वो हो गया. So is this clear, guys? Let me know quickly. Okay, good. अब हमारा ये तो हो गया. Now we are done with the easy part. Now we are going to be doing a bit of a difficult thingy, which is a bit of a difficult concept, which is basically, equal. Yes. So the new concept will be addition. Oh, just a moment. Addition of binary numbers. Now we know addition of, I guess the addition spelling is wrong, but let's leave it. Addition of binary numbers. Now, if I say and ask someone, what's 12 plus 5? We all know 12 plus 5 is what? A 17. If I say 19 plus 13, what's the answer going to be? 9 plus 3 is 12, but we can't write a 12 up here, so it will be 2 with a carry, and then 1, 2, 3. It's going to be a 32 is the answer. Okay, and just like that, 17 and let's say 15. What's going to be the answer? 7 plus 5 is what? It's again 12. Okay, so 2 and then up 1 up here, so again 32. Now this is when we deal with the denary numbers, right? But what if just a moment, what if we have something like binary number 11001101, and I add 00100101? If I say add the two numbers, how will I be adding them? So this new concept is known and referred to as addition of binary numbers. We do get a lot of questions related to this, and this is something which you will be tested in your AS level. So it's a very, very important concept. It's super important that you guys understand it, and it's something really cool too. So how do I add it? There are some rules which you need to memorize first. Let me add the picture up here from files, and I just download it. It's somewhere up here, downloads. Where is it? Yeah, up here from the book, directly from the book. So look at this. We have this specific addition of binary numbers section from the book. It's basic maths. Yeah, it is basic maths, but there is a catch to it. When we are adding binary numbers, we can either add 0 plus 0. Ignore this for now, okay? Ignore this. We will be looking at this later on. But Have a look at this. Let's say we are adding two binary numbers. Okay, we have some specific rules. We could either add a 0 and a 0. Okay, it could be either a 0 plus 0, like something of this sort, 0 plus 0, or it could be a 0 plus 1, something like this. Okay, or it could be a 1 plus 0, maybe something like this, or finally it could be something like a 1 plus 1. Now what's the difference and how do we do it? So this above example, in this example, see, when I added 19 plus 13, what happened? I couldn't write 12 up here, right? We couldn't do it. So what did I do? I wrote a 2 and I took 1 to the other section as a carry. So when dealing with binary numbers, we always have to look for carry. And there are some specific rules. You need to memorize this. Whenever we are adding 0 and 0, so let me just make this plus sign so it's much more clear. So whenever we have something like 0 plus 0, we need to write the answer as 0, like it's going to be a 0 up here in the answer. But we will also have, and this will be your answer. Let me make it like this, answer, and then we have a carry, and the carry will also be a 0. Okay, this is something you need to memorize. Let's say we have a 0 plus 1, the answer will be 1. Okay, but the carry will be a 0. And then let's say we have the other way, 1 plus 0, the answer will be again just like before, a 1, the carry will be a 0. But if we have a 1 plus 1, the answer will be 0, but we will have a carry. Okay, no, it won't. Okay, so now that's a question. 1 plus 1 is usually 2. Okay, 1 plus 1 is what? It's 2. But I have a question. Can we write 2 in binary? Like, didn't we study that binary is a base 2 number system which can only deal with zeros and ones? Where did the number 2 come from? Guys, it's something really important. Okay, so we cannot have 2 at all. Yes, exactly. Because binary, computer understands binary, right? But 1 plus 1 is 2. 2 is not a binary digit. So how will the computer understand? So in order to tackle this issue, the programmers basically came up with this method where they said that if we add 1 plus 1, we could write the answer as 0, and then we could like have a carry onto the next section, and it could be something like 0 plus 1. Guys, I'm getting like a lot of calls today. I don't know for what reason, Allah khair kare, but let's continue. So 1 plus 0, it's going to be 0. Now, if we saw the above question, how am I going to be doing it? So 1 plus 1. Yeah, let me just decline it, guys. आप लोग को भी इसी वक्त कॉल्स याद आ जाती हैं, but चलो, 1 plus 1 is what? 1 plus 1 is a 0, right? 1 plus 1 is a 0. So I'm just going to be writing a 0 up here, but carry 1. So I'm going to take a 1 up here. Now look at this, 1 0 0. Now I missed one thing. If we have something like 1 plus 0 plus 0, now look at this, like rather than me writing it, just have a look at this. Whenever we have carries or something of that sort, we will have it like this. If we have 0 plus 0 plus 0, it will be 0 either way. The carry will be 0, the sum will be 0. If we have one single one in it, we will have the sum thingy as 1, whereas the carry will be 0. Same applies for either of the positions. Okay, and but if we have two ones, and 1 0, what's going to happen? The sum answer will be still 0, but your carry will be a 1. But the rare exception to all this is that if you have 1 plus 1 plus 1, if we have a 1 plus 1 plus 1, in that case, our answer will also be a 1, and the carry will also be a 1. So 1 plus 1 will be a 1, and then the other one, we will also have a carry. So these are some rules you need to memorize. And also, if you do some question, this will be something aap log ko khud hi samajh aa jayega. So 1 plus 0 plus 0, this is exactly this one. 0 plus 0 plus 1, okay, or 1 plus 0 plus 0. So what's going to happen? This carry is going to be 0, whereas the sum is going to be 1. So 1 plus 0 and 0, it will be a 1 up here. Then 1 plus 1. A 1 plus 1 is what? It's a 0 with a carry. Goes up here. Now, again, 1 plus 1 plus 0. Again, we have two ones. So whenever we have two ones, remember, our answer is going to be a 0 with a carry. So two ones, again, 0 with 1 up here. 1 plus 0 plus 0. Just a single one, right? So a single one, just bring the 1 down up here. Again, 0 and 1. Single one, just bring the 1 down. 1 plus 0, again 1, and finally 1. Did I mess up somewhere? 1 plus 1 is a 0 with 1, and then 1 0 0 is 1. Then 1 1 is 0 with 1, 1 1 is 0 with 1, and this is going to be a 1, and this is also. Hussain, can you check if your answer is correct? I'm getting the answer as 1 1 1 1 0 0 1 0. Also, I will show you guys a quick shortcut on calculator on how you can like type of add the numbers. It's pretty easy. Let me see binary addition. Let's confirm everything. No worries guys, आप लोग खुद करो. Oh yes, yes, no worries at all. करते जाओ, कोई उसमें ये वाला मसला नहीं है. So एक सेकंड रुकना यार. एक सेकंड. अच्छा. So you get the answer as 1110010. So the main thing is shortcut ye yaad rakho. Whenever we have single one, just bring the one down. Bring the one down. Bring the one down. If we have two ones, we have the answer as zero. Answer will be a zero. A carry will be a one. Okay, this is the most simplified answer I can give you all. Okay, and then if you have three ones, you have the answer also as one, and you have the carry also as one. So you have overall 111. Now let's do a question again. Okay, this time let's do it in a way. Let's do it like yes, Afula, if you have a question, let me know. What's the question? Let's drop in the questions in the chat box. मैं जवाब देते जाऊंगा. Chill scene, कोई मसला नहीं है. So let's make a number, not 16, something big. 30 कर लेते हैं. Okay, so 1 2 4 8 16 32 64 128. So how will I be writing 30 in binary? ऊपर करके. Okay. So 128 64 32 16 8 4 to 1. 30 करना है. So 0 0 0. 16 plus 8 is what? It's 24. 24 plus 4 is what? 28. 28 plus 2 is what? 30. So we get this as 30. This is basically what? It's a 30. So yeah. And now let's do 14. So 14 will be what? 0 0 0 0. 8 plus 4 is 12. 12 plus 2 is 14 and 0. Now if I add the two numbers, I should be getting an answer of 44. Okay, and either way, whether you are dealing with denary numbers or with binary numbers, you should be always getting the same exact answer. You can always check it, and if you're not getting the same answer, this means you made a mistake somewhere. So now let's do it. 0 plus 0. So no zeros, no ones. This means answer also 0 and carry also 0. Okay, just one other element to it. So 0 plus 0 is what? It's going to be a 0. 1 plus 1, two ones, answer 0, carry 1. So 1 plus 1 is going to be a 0 with a 1 up here in a carry. Now we have three ones. 1 1 1. What did I say? 1 1 1 will be an answer with 1, and the carry will also be a 1. Again, 1 1 1. Answer 1 and a carry 1. But now 1 1 0. Two ones, right? So the answer is going to be a 0 with 1 carry. 1 plus 0, so just a single one. Just bring down the 1 and then 0 0. So now let's convert this binary value into the denary number. What will it be? We have a 32. See, we have a 32 from here. This is 32. This is 8 and this is 4. So 32 plus 8 plus 4. We exactly get the same answer, 44. Hence proven that our method is 100% correct. Did you guys get this? This is the most simplified shortcut method which you guys can know. If there are no ones, answer is 0, carry is also. If there is a single one, bring the 1 down. If there are two ones, the answer is going to be 0 and the carry will be a 1. If there are three ones, answer will also be 1, a carry will also be 1. So is this clear? Good. अब एक और question करते हैं, because this is something which requires a lot of practice. Okay, the more you practice, the better you will be in it. So let's do it up here. Guys, give me some numbers. Yes, exactly. Give me some numbers. Quickly. Some big numbers. Jaldi. 18 and quickly. Anyone else? We got 18. Okay, 18 and 39. So we have 18 plus 39. What will be this answer? Let's first do it this way. 13 plus 18. So 9 plus 8 is 17. Right? So 1 is going to go up here. So 3 4 5, we get the answer as 57. Guys, if I make some sort of error, you guys are more than open to correct me. Okay, ye bilkul nahi sochna ki galti hai, to let's ignore it. No ignorance, just correct me. I'm also just someone like you. I'm open to learning, and you guys should always be learning. I'm telling you, computer science is a field where if you think you will stop learning, This means you are going to get vanished. If you are someone who is open to learning, you will always grow, always grow. Okay, so remember this tip of mine. So 57. Let's make the binary value for 18 first. 1, 2, 4, 8, 16, 32, 64, 128. And guys, we haven't used a new pen color. Let's change the color. It's important. Let's do it in orange. Okay, so we haven't used orange. Anyone? Yeah, okay. Thank you, Saifullah, for explaining it for the others. So we have 18, right? So 18 हम किस तरह करेंगे? 0, 0, 0. 16 plus what is 18? 16 plus 2 is 18. So we will be putting a 1 under the 2 number and 0, 0, 0. So this is basically 18. Okay, let's write it up here. 18. This is 18's binary number. The second one is 39. 0, 0, 32. Yes. And what do I need to add into 32 so that I can get a 39? It will be 7, right? 32 plus 7 will be 39. So it will be a 0 up here, 0 up here. 4 plus 2 is 6, 6 plus 1 is 7. So we get this as 39's binary. Now let's add the two numbers. 1 plus 0. What's the rule? If we have a single one, bring the one down. So 1 plus 0, bring the one down. 1 plus 1, 2 ones. Your answer should be a 0, whereas your carry should be a 1. So 1 plus 1, 0 with a 1. Again, 1, 1, 0, 1. We have two ones, 0 with a carry. Single one now, 1, 0, 0. Just bring the 1 down. Again, 1, 0, single one. 1, 0, single one. And 0, 0 will be 0. Now let's convert this back into the binary thingy. So we have ones where we have a 1 up here with the 1 number, then we have a 1 up here with the 8, and then 16, and then with 32. So if we add the numbers, if we add these numbers, which are basically 32 plus 16 plus 8 plus 1, what do we get? What do we get? Just a moment, let me calculate it. It should be the same, 32 plus 16 plus 8 plus 1. Guys, we just got a 57. 57, 100% perfect answer. We firstly, if I get a question like this on the exam, I will be first doing it like this, and then I will be making a small calculation on the side, which I could later on cut off like this. Okay, remember, when you do something like this, just like cut it off so that the examiner knows that you are only trying to do it to clarify and check your answers. Okay, no need to tell them that I solved the entire question like this. It's really important. Like, in the first step, okay, so the first step, remember, see, first let me complete this. This is really important when you're given a question like this, where let's say you have to add two binary numbers. And if I show something like 39 plus 18, 57, and I just plot the 57, like I can do it this way too, right? So if I do it like 39 plus 18, 57, and I just give this in the answer, I won't be getting the marks. Remember, such questions are worth 2 to 3 marks, and these marks are only awarded when the examiner can clearly see. When they can clearly see that, oh, this person, yes, he wrote the binary for 18, 1 mark. He wrote the binary for 39, second mark. And he is also dealing with carries and performing the correct answer, getting the correct answer. Perfect, 3 on 3. So you can do that. That's what I'm trying to say. That let's say if I just add up the binary values, like you see, I just added up 39 and 18, I got a 57. Now if I plot this 57 in the answer, I get the same thing. Like 57 could be, if I plot it at the binary thingy way, it's going to give me the same 00, 111, 001. But the examiner won't be marking you for this. Understand this. It's really important that the examiner won't be giving you a single mark for this. So इसलिए जरूरी है guys, एक सेकंड, मैंने एक चीज सेटिंग देखनी थी. लेट मी सी मेरे वो सेटिंग फुल एचडी पे है या नहीं. यस इट इज. चलो गुड. चलो, इसलिए इट्स रियली इंपॉर्टेंट दैट whenever you do something, just to check your answers, always cut it off. And I will personally advise, do such rough work on a pencil, because pencil usually check nahi hoti and it's a clear indicator. A pencil is used for rough work. Okay, so a pencil, let me write it up here. Never attempt your paper with pencil. Remember, pencil equals rough work. Remember, Pencil equals rough work. If you attempt your paper with a pencil, you might not be awarded a single mark, even if you have done a top in world level paper. Okay. So Saifullah asked a question: can you explain the addition in first step? Yes, why not? Let's do another example. Maybe that helps you with the whole concept. Let's say we have double one double zero one zero one zero, and I add it into zero one one zero one one zero one. Okay. Now remember, I will rewrite the rules up here. Remember, memorize this rule. Okay, it's really easy. No one's, this will be your answer. The answer refers to the lines. This section is your answer. Okay, this is answer, and then this is your carry part. Okay, answer and carry, answer, and then this is carry. So no ones, if you have no ones, your answer will be a zero and a carry will be also zero. No ones basically mean you are dealing with zero plus zero or something of that sort. If you have one, okay, if you have just a single one, bring the one down, which means that you will be having a one in the answer and a zero in the carry. If you have two ones, if you have two ones, the answer will be a zero and the carry will be a one. If you have three ones, you will be having an answer of one, also the carry of one. So if I add this, 1 plus 0 comes under what section? It comes under this. Sorry. 1 plus 0 comes under this. You will be having an answer of what? 1. And a carry of what? 0. So no carry at all. Again, 1 plus 0, same, single one. So 1. 1 plus 0, single one. 1 plus 1. 1 plus 1 is what? 2 ones. So we will be having a 0 in the answer, and then we will be having 1 carry. Now I have a carry up here. This comes under a single one. We have just one, right? 1. So what? The answer will be a 1 with no carry at all. Then 1 plus 0, again single one, just 1. Then 1 plus 1, we have 2 ones, right? So the answer will be a 0 with 1 carry. And now this is something really okay. Abhi samajh aayi question ki, but this is also something really important. Guys, have a look. 1 plus 1 is what? A 1 plus 1 is a 0 with a 1 carry. But now the issue is that we only have an 8-bit register. Where does this number go? Where does this one go? This one comes under the same overflow error which we were discussing previously. So now this one, basically, this is an overflow error. Overflow error. So if you are asked in the exam that where did an error has been caused during the execution of the addition of two binary values, name the error, then you are supposed to write overflow error. This is an overflow error. Why is it an overflow error? Because we don't have a space for it. We already said that we only have a 8-bit register, whereas if I want to include this carry, it will go to a 9th bit, right? 9-bit slot, but we don't have a 9-bit slot. If the register was maybe a bit bigger, of 12 bits or 16 bits, then maybe we could have included the carry somewhere. But because we don't have that, we are going to ignore the carry, and this will go onto the overflow section. And so the error, usually this gives you an error. Okay, this gives you an error. So whenever you get an error, when you have a value which needs to be stored but you don't have the relevant space for it, it is known as overflow error. Overflow error, really important concept. Usually they do ask about the question. Now Saifullah said that can you explain the number addition? So I was just talking about कि देखो, if we add these two numbers 18 and 39, we get a 57. Okay, so if we perform the binary addition, we get this as the answer. This is the binary for 57, right? But an easier way could have been कि अगर मैं 39 plus 18 खुद कर लेता, I could have gotten 57, right? And then I could have plotted a 57 like this: 1 2 4 8 16 32 64 128. So I could have just placed 1 1 1 1 0 0 1. Now this will also be giving me a 57, right? But I'm just saying that whenever you do something like this where you want to confirm your answer, uske baad isko cut karna, and you need to show working. You need to show working, because if you don't show working always. Show working always, because if you don't show the working, the examiner can always think either you are cheating from someone firstly, or you have an access to a calculator. I will give you, just for your own information, you can always add binary numbers using a calculator. Okay, but you won't be allowed calculators in your exams. Do remember that. And the third thing could be कि examiner खुद बोले 39 plus 18 is 57. Maybe he directly plotted ones under the specific position just so that he can get a 57. Now, if you do this, he won't be giving you marks. Why? Because he might be thinking कि आपने directly numbers add करके उनको plot कर दिए, right? So हाँ हाँ बिल्कुल, इट्स जस्ट लाइक दैट. अब देखो मैंने 57 करना है. दिस इज द फर्स्ट लेसन कि आपने बिल्कुल ही देखना है कि कहाँ कहाँ पे मैंने प्लॉट करना है. सो 57 इज स्मॉलर देन 128 देन 64. तो यहाँ पे हम जीरोस करेंगे एंड देन 32 पे 1, 16 पे 1, 8 पे 1. सो व्हेन आई ऐड द कॉरेस्पॉन्डिंग वंस आई विल बी गेटिंग अ 57 एज माय फाइनल आंसर. द इंपॉर्टेंट थिंग अप हियर इज कि आपने डायरेक्टली इस तरह नहीं करना कि आई ऐड अप द टू डेनरी नंबर्स एंड देन plot the binary for the final answer. You need to clearly show कि आपने दोनों की binary find की, then you added the two values, and then you that you are also dealing with what do we call it, guys क्या बोलते हैं इसको, carries and all. So ये सब करोगे तो you will get the marks. So we just studied how do we add binary numbers. Now we also need to study subtraction. Okay, I guess we don't have enough time. We will be discussing that in the Monday's class, which means that this chapter might go till Tuesday or Wednesday, because once we are done with subtraction, then we are going to be dealing with some other cool OSCE tables and those stuff. Those are cool things. No need to worry at all. I just want to give you all a quick, yeah, inshallah, Monday ko hogi. It will be a demo class, okay? And let me just have a screenshot from the syllabus कि हमने कितना cover कर दिया. It's really important. Usually teachers don't show the syllabus part. I will explain how you need to be overlooking your syllabus regularly. Even if I'm teaching or something, आप लोग खुद देखो. It's really important. Syllabus is something really crucial because it tells you what you have studied till this very moment, and it also helps you understand, have I missed or the teacher missed something which is there in the exam which might be tested. So let's bring the syllabus up here. So bring it up here from files and then go to desktop, and this is the screenshot. Okay, so let me open it up. Let me make it a bit bigger, and I just rotated it a bit. So yeah. So now guys, have a look at this. The first thing, understand how and why computers use binary to represent all form of data. You always have notes and guidance if you forget कि हम क्या करें. So you see, any form of data needs to be converted. We have already studied this, right? So that a computer only gets data in binary. It doesn't understand the conventional thingy. Then we also discussed that data is processed using circuits. Remember, those circuits are referred in computer terminology as logic gates, which is a proper different chapter number 10, which we'll be studying it later on. And then we talked about registers, right? We dealt with 8-bit register, 12-bit register, and all that. Then we discussed denary is a base 10 number system, binary is a base 2 number system, hexadecimal is a base 16 number system, and that we have discussed all these values will be used. So whenever we are dealing with denary numbers, we are only going to be dealing with what, 0 to 9 values. Okay, and then we studied the conversion, denary to binary or binary to denary. We're done with that. Okay, we didn't do this maximum binary number length. Okay, I guess this is with the do we have negative? Okay, this is something we missed, and this is the benefit of overlooking the syllabus. So guys, do know that whenever we are dealing with binary numbers, the maximum binary length is of 16 bits. 16 bits. Just remember this. They might be giving you a question, maybe tick in the box. We had a question like this at our time. A question could be, what's the maximum binary length? 16 bits, 25 bits, or a 40-bit? You just need to put a tick in the 16-bit thing. Okay, so do remember, whenever we have binary numbers, the maximum binary length will be 16 bits at your course. And when I say 16 bits, it basically means that you can maximum. If I go back to this hexadecimal section, I already discussed something of this sort, but not in great depth. A second, where is the hexadecimal number? So remember C5A3. C5A3, we had this number. When I converted it, the maximum we had was 16 bits. See, I already wrote it, 16 bits in binary. This means that when you, in your IGCSE or O-level computer science, the maximum bits they can give you are 16. This doesn't mean that you can't have more than 16. You can go up to like 128 bits, 256 bits. But at your course level, the maximum they can give you for your like maybe for conversion or maybe for addition, not for addition, but for like hexadecimal and all that, are 16 bits. So like maximum hexadecimal number you can get is something of C583, which would be something like this long. Now these are 16 bits. How 16? 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16. So ये हो गया सही है. And फिर इसके बाद let's go down quickly. Then areas within computer science that hexadecimal is used should be identified. We already saw where do we use hexadecimal. We discussed MAC address, IP address, we discussed error codes, we discussed the color codes in HTML languages. All those were the areas. And why do we use hexadecimal? Because it is easier to understand, it is shorter, and it occupies less RAM space. Routers, yes, देखो at your course 16 is the limit. It's just so that the examiner can test you कि like 16 तक हो सकते, तो इसका मतलब वो और भी कर सकते हैं. सही, this is the main reason. Usually you are not even tested with 16 bits. Your most of the questions are only till 8 bits. Remember, you will be dealing with 8 bits. If a rare question comes with 12 bits, there is a possibility. And I haven't personally, I guess I haven't seen a question with 16 bits. But if it comes, don't be like it's out of the course. No, it's there in the course. See, it's clearly written. That is why syllabus is very important. Then we studied add to positive 8-bit integers, right? See, it clearly mentioned 8-bit. This means when, so the harder education book, okay, the harder education book, if you open that book and you go to the practice section, there are a few questions where you are asked to add 12 bits. Okay, you are asked to add 12 bits. That's for your practice. But see, your syllabus clearly mentions that you only need to add 8 bits binary integers. So you should not be practicing those. You should not be just tiring yourself by doing those questions. It's really important. Then understand the concept of overflow and why it occurs in binary addition. We already studied that. Overflow is what? It is an error which will be occurring if the value is greater than 255 in an 8-bit register. What does this mean? It basically means that this binary register, if I add the values 128, 64, 32, 16, 8, 4, 2, 1, if I add the values, it's going to give me 256, 255 ideally. Okay, it's going to be giving me a 255. If I want to get a number up here, like a carry up here, this basically means that if I put a 1 up here, the 1 should be having a value of 256, right? We do know. So 256 is greater than 255. But because we don't have area or a slot for that, it goes into the overflow section. So in the syllabus, it has been mentioned as that an overflow error will be occurring if the value is greater than 255 in an 8-bit register, which basically means the same thing, that if it goes out from the maximum capacity which we have, then an overflow error will be occurred. And why does that occur? Because our computer has a predefined limit that it can represent, or in simple words, as I mentioned earlier, because we have limited slot in a register of 8 bits, that we can only store 8 bits. We can't store the 9-bit slot in an 8-bit register. For that, we might need a larger register. And so it says that if we have a predefined limit, so we can go outside. And if a value goes outside the limit, an overflow error occurs. Okay, and this limit should be returned. What does this mean? This basically means that in computer science, when we say return, this means that the value is outputted to the screen, or like it's shown at the screen, and we no longer look at it in calculations, or in simple words for all of you, ignore the value. Ignore the value. There is a bit of complex terminology used, but ये ऐसा है कि आप लोग end में इसको जब फिर से पढ़ोगे तो you will understand in a much better way. So we have studied conversion between positive binary, we have positive denary, positive hexa, and positive binary. Understand why it is used. Done. So we are mostly done with most of the things at this specific section. In Mondays and Tuesday class, we will be quickly doing 1.2 and 1.3 inshallah. And फिर उसके बाद that's it for today, I guess. And I guess आप लोग को no, there you don't have to add hexadecimals. Okay, I'm not even sure if we can add them. Maybe there might be a method. No, I basically did say कि chapter number 1 Monday तक तो है demo classes. I'm not sure, maybe Tuesday के ना हो, but that's all for today. Let me just end up the recording. किधर गए? Yeah, inshallah. Proper classes, these are like अभी से भी proper ही हैं, tension ना लो.